All right, welcome to our first video for this unit, Task 2, Central Angles. A couple little definitions to start off with. A central angle is essentially any angle inside my circle where the vertex, this point right here, is at the center of the circle. And its two sides are made up of radii, two radiuses. It's really just radius, plural. And so, for example, this angle right here, angle ABC, is a central angle. One thing to note when you make a complete circle, the sum, if I were to add them all together, the sum of all central angles in a circle is 360 degrees, right? If you turn in a circle, you turn a full 360 degrees. And so the measure of an arc, essentially this part of the circle, the curved part, that measure is the same measure as the central angle. So the endpoints of a central angle is equal to the degree of the central angle. And so I have this angle ABC is 84 degrees. That means that this arc AC is also equal to 84 degrees. And that M right there just means measure. Measure of that arc AC as 84 degrees. And since I know that this full circle equals 360, when it asks me the measure of ADC, ADC is this section of the circle, right? ADC is that whole section of the circle. And so I'm going to take 360 minus 84, and that would give me the degrees of that arc, which is 276. All right. So the angle inside is equal to the measure, the degree of the arc outside. Angle inside is equal to the arc outside. As we work through these, there's a couple vocab words that I want to remind ourselves of. One of those words is supplementary. And so supplementary simply means that they add to equal 180. And so angles that form a straight line add to equal 180. So if this was, I don't know, 100 degrees, that would mean that that angle right here would be 80 degrees. They add to be 180. The other special angle that we have learned about in the past is vertical angles, angles that are across from each other but share that same vertex. Those are congruent. In other words, they are equal to each other. So if this angle is 48 degrees, that would mean that that angle is also 48 degrees. They have the same two intersecting lines. They're directly across from each other, the exact same size. So we're going to remember this as we start trying to figure out some central angles and arc measurements. So this first one, we're asked to figure out the measure of ST. Well, ST is essentially the arc right here. And we are given the fact that this angle is 122 degrees, which means that that arc is also 122 degrees. Now, the measure of the arc RS is a little bit different, right? So RS is essentially this space right here. But the nice thing is that these two angles make a straight line. And so I have the measure of RS I'm going to take 180 minus 122 to figure out that angle measure. And that angle measure is 58 degrees. And so since this angle is 58 degrees, this arc is also 58 degrees. Now the last one is the measure SRT. SRT. So that is going from S all the way around to the R, all the way around to the T. This big section of my circle. I'm essentially including this semicircle, which is 180 degrees, plus this arc, which is 58 degrees. So I'm going to take 180 plus 58, which gives me a total of 238. So that measure of SRT is 238 degrees. All right. Number 2, we're going to start using some vertical angles here. Notice these ones across from each other are vertical. Angle JNK and angle LMK are vertical. So that means that this one is also 21 degrees over here, right? I got 21 degrees here, 21 degrees here. I can also make a quick note that those two angles are also congruent. So angle K and L over on this side of my circle, angle K and L. And the angle over on the other side of my circle, J and M, are also vertical. I'm sorry, this one should be L and M. That is silly. L, M, L, and M. Gosh, why can't I write that right? L, and M. Goodness. Okay. So I have these vertical pairs, one across from each other. These two are equal to each other as well. So let's really quickly, arc JK, this one's 21 degrees, so that means that arc JK is also 21 degrees. But then it's asking for J and M. J and M. Well, J and M is this section right here. Right, that angle J and M, which we know is exactly equal to this side. The nice thing is that it does make a straight 180 degree line with an angle that I already know, 21 degrees. It makes that straight line with the angle I already know. So for J and M, I'm going to just take 180 minus 21 because it makes a straight line with that 21 degree angle. And so I get an answer of 159 degrees. KL is right across from that. That's my vertical angle. It's going to be the same exact thing because it's my vertical angle. It's also 159 degrees. Then I have JKM as my next one. JKM. Let me take a different color. JKM is wrapping around my circle, and I have this 21 degree angle, this 159 degree arc, 21 degree arc, 159 degree arc, and another 21 degree arc. So JKM is going to be 21 plus 159 plus another 21. When I add that all up, I get a total of 201 degrees. And then the last one is MKL. MKL, which means I go from M to K to L without going the other way. I'm going to go around this direction, M to K to L. Essentially the entire circle minus that ML arc. So I'm going to actually just subtract for this one because that sounds a little bit easier. MKL. I know a full circle is 360. So I'm going to just subtract away this little 21-degree chunk that I'm not using. So 360 minus 21 gives me a total of 339 degrees. And my last example, the last box, measure UXV. UXV is right here. The nice thing is that it is vertical. UXV and angle SXW are vertical. So that means that this one is also 72 degrees. Now ST is just this little chunk right up here, ST, but I already know that this is 72 degrees and this is 87 degrees, and they all make this straight line right here. So in order to figure out what ST is, I'm going to take 180 minus this angle, 87, and minus my other angle, 72. And I'm going to subtract 180 minus 87 minus 72, and I get 21 degrees. All right, the next one, WV. WV. Well, WV is right here. I can kind of do the same idea with that straight line. WV, I know this is 72, and they make that straight line, so I'm going to take 180 minus 72, and it gives me 108 degrees. My next one is TW. TW. So that is T to W. That is just this section right here. TW. So I'm going to add together those two arcs. 21 plus 72, which equals 93 degrees. And my last one, TVW. So I want to go from T to W, but instead of going directly to there, I got to go hit V first. So I'm going to go TVW, and I'm going to add all of those in between. I know that WV is 108. I know that this is 72, and this is 87. So TVW, I'm going to add together 87 plus 72 plus 108, which gives me a total of 267 degrees. And now it's your turn to try these 6 problems right here.